Hello guys, welcome back to your physics class. In a previous lesson, if you remember, we finished section 2 in chapter 6 about the generator, motors, and mutual inductance. Today's lesson we are focusing on section 3 in chapter 6 about the effective current. And today's lesson we will talk about the effective current. And before we get started, we have a definition of a digital multimeter or a voltmeter. What is digital multimeter? A device that can be used to measure resistance, current, and potential difference. Okay, so this is a digital multimeter, an electrical device that can be used to measure resistance, current, and potential difference. If you remember, we studied the generator. An AC generator could produce an alternating current that varies as a sine wave with respect to the time. And the EMF epsilon in AC circuit is analogs of the potential difference in DC circuit, which is volt. Guys, just for reminding you, we have 3 different types of current. In section 2, you have learned about the different types of current. So a quick reminder to all of you, the different types of current. We have AC current, which is, it is magnetic and direction of the current changes continuously. And we have DC pulsating current in DC generator. In DC pulsating current, only the magnitude of the current changes. Its direction doesn't change because of the commutator. And the third type of the current is DC battery. In DC battery, guys, not magnitude nor direction doesn't change in the DC battery. In DC battery, the amount of the current, the magnitude and direction of the current doesn't change. Neither magnitude nor direction changes in DC current, like the current of the battery or DC battery. Okay. Effective current and effective potential difference are measured in AC circuit. Guys, in AC circuit, like in the generator, alternating current. What do you mean by AC or alternating current? It means that the magnitude and direction of the current changes continuously from 0 to the maximum, 0, maximum. Okay? In AC generator, the magnitude and direction of the current changes continuously. Okay? The peak value is called maximum current, V or I, or maximum potential difference. At the peak point, okay, at this point, the peak point is called the maximum value. Maximum value of what? Of current or potential difference. When does the current in AC generator reach its maximum value? When the plane of the loop is parallel to the direction of the magnetic field. As the plane of the loop orientation becomes perpendicular, the magnitude of the current and potential difference becomes what? 0. Okay? At this point, the value of the current and potential difference is 0. At this point, also, the magnet of the current and potential difference reaches maximum, but in negative direction. Okay? So it means that in AC generator, we have maximum values. Okay? And also we have instantaneous values. The instantaneous values, it means that the potential difference and current at each instant. The blue dot represent for what? Represent for instantaneous current or instantaneous potential difference. Guys, how can you determine the instantaneous current or the current at each instant, potential difference at each instant? By using this relation. Potential difference, instantaneous potential difference is equal to maximum potential difference sine omega t. And by using this equation, you can find the magnitude of instantaneous potential difference. How about instantaneous current? How can you determine instantaneous current? By using this relation. I am sine omega t. Okay? So it means that in AC circuit, we have maximum value and instantaneous value. I instant, sorry. The blue dot represents for I instant or V instant. And we have another value in AC circuit, in AC generator, is effective current and effective potential difference. This directed line, this steady line, is represent for what? Effective current or effective potential difference. So finally, we can say that in AC current, we have three different values: maximum values, instantaneous values at each instant for each of the current and potential difference, and effective values, effective current or effective potential difference. How many values do we have? Three: maximum values, instantaneous values, and effective values in AC circuit. Okay? In AC current, look, AC current, we have effective value of current, effective value of potential difference, instantaneous current, instantaneous potential difference, and we have maximum current and maximum potential difference. In AC current, we have effective, instant, and maximum values. But in DC current, guys, the situation is completely different. DC current, DC circuit. In DC circuit, we have only the maximum value. The function of time, this is V or I. In DC current, guys, in DC current, only we have maximum value. Okay? We have only IM or VM. In DC battery, the DC current of battery, we have only one value, which is called the maximum value. Okay? We don't have effective in DC battery. We don't have, when we say DC circuit, DC of battery. Okay? Not DC pulsating current. We don't have instantaneous, only we have V maximum and I maximum. Okay, guys, what is effective current? Now I'm going to explain in detail. It's very important. What is the effective current and what is the relation between power dissipation in AC and in DC? Power usually dissipated in the resistor. Okay, in the resistor the power will dissipate, but in the inductance, in pure inductance, in capacitance, power doesn't dissipate. Okay, so it means that in resistor we have energy loss. The energy like converted from electrical energy into the thermal energy in the resistor. Okay, assume that we have two sources, AC source and DC source. Okay, connected with the resistor with a light bulb, for example. Okay, connected with the light bulb. The resistor of the light bulb is equal to, for example, 5 ohm. The resistor doesn't change. It doesn't matter connected with AC or DC. Okay, this is DC, this is AC. In AC, current represented as a sine wave, but in DC, the current is steady, doesn't change. This is positive and this is negative. Assume that the maximum current in DC, only we have maximum 10 ampere. The maximum current in DC is equal to what? 10 ampere. This is maximum current in DC. And maximum current in AC, maximum current in what? In AC is also 10 ampere, which is this point, 10 ampere, 10 ampere. Only at one instant, the maximum current reaches 10 ampere. The other is not. Only at the peak, maximum current in AC is equal to 10 ampere. But in DC, this 10 ampere is continuously 10 ampere all the time. Doesn't change, doesn't decrease. Okay? But in AC, only at one instant, the maximum current is equal to 10 ampere. Guys, when current flows through the resistor, I am 10 ampere. I am here is also 10 ampere. Guys, which one has more power dissipation? Look, this is a very good question, be careful. Which one has more power dissipation? In which case we have more power dissipation, we have more power loss or power loss? 5 ohm resistor in AC with maximum 10 ampere, or 5 ohm the same resistor in DC with a maximum value of 10 ampere? Absolutely, the DC source has more power dissipation. Why? Because the power dissipated by the current, okay? The current in DC continuously is 10 ampere. It doesn't decrease. But in AC, current is 10 ampere only at one instant, at the peak. How about at this point? Current is 0, okay? In AC, is it possible to current to reach 0? Yes, of course. But in DC, current continuously steady and always maximum value. Guys, now I'm going to prove why power in DC is bigger than power DC, and power in AC, guys, look. Power in DC twice as power AC. The power in DC is bigger than power in AC by factor of 2. Power DC is twice as much power in AC, okay? How can you determine the power dissipation? Power dissipation in DC is equal to I squared R. Power dissipation in AC is equal to I squared R. What is the difference between these two equations? In DC, how many values do we have in DC? Sorry, this is AC. This is AC and this is DC. Guys, in DC, how many values do we have? We have only the maximum value. So which value do you have? Maximum only. Power DC is equal to what? IM squared. IM is equal to what? 10 ampere. 10 squared times 5 is equal to, power in DC is equal to what? 500 watt. But power in AC, guys, in AC, how many values do we have? We have maximum value, instantaneous value, and effective value. Okay? So in this equation, we have to use the effective value, IE squared R. Okay? Which type of value, which type of current can be used to determine power dissipation in AC source? Only effective. Because in AC source, which value of the current dissipate the power? Maximum or effective? Effective current. Power AC, we have to use IE squared times resistance. But in DC, we have to use maximum because we have only the maximum. Okay? Guys, look. Power DC twice as power AC. Okay? Power DC, now I'm going to prove this equation, IE is equal to IM over radical 2. Power DC is equal to what? IM squared R. Bring down 2. Power AC, I effective squared R. In AC, we have to use effective, but in DC, we have to use maximum. These two resistance cancel to each other. What does remain? IM squared. 2 times IE squared times radical to remove this square. Radical IM squared. Radical 2. Radical IE squared. Square with radical remove. What does remain? Only IM. Radical 2 times, or you can say, radical with square cancel. What does remain? I effective times radical 2. This is the relation between maximum current and effective current. Maximum current always bigger than the effective current. So the effective current is always located below the maximum current. If you rearrange this equation, IE is equal to what, guys? Is equal to IM radical of 2. I effective is equal to what? IM radical 2. Guys, do we have IE? No, we have IM. How can you determine IE? IE is equal to what? IM radical 2. IE, the effective current in AC source, is equal to I maximum divided by radical 2. 10 divided by radical 2, I effective is equal to 7.5. like something like, let me calculate. Guys, 10 divided by radical 2, 7.07. 7.07 ampere. Now, we can calculate the power dissipation. Power dissipation is equal to what? IE. Do we have IE? We didn't have, but we found. This is IE. 7.07 square times resistor 5. Look. Power in AC is equal to 7 square times 5. I got 250 watt. The power dissipated in this resistor is equal to, power is equal to 250 watt in AC. Now, let's find power dissipation in DC. It should be twice as AC, 500, okay? It should be 500. Now I'm gonna prove. Guys, power in DC, yeah, I solved it. Power in AC in DC is equal to what? 500. Which one is bigger? Power in DC or power in AC? Absolutely power in DC. Power DC 500 watt, but power in AC 250 watt. Which one is bigger? Power in DC. By which factor? Factor 2. Power dissipation in DC with the same value of maximum current in both AC and DC is twice as power in AC circuit or in AC current. Okay? So in this way you can determine the effective value. What is effective value? The value of what? Effective value. The effective value of current and potential difference is the value of what? Of AC circuit. That gives the same heating of DC current. Another example, guys. Another example. If you have two circuits, AC and DC, connected with the resistor 5 ohm. Resistor still 5 ohm, same thing. If the effective current of this AC source is equal to 10 ampere and maximum current in DC is equal to 10 ampere, how many currents do we have? 2. Maximum current in DC 10 ampere and effective current of AC. This is not maximum, this is effective. Effective current of AC is 10 ampere. Which one has more power dissipation? Same. Why? Because the effective value of the AC current has the same effect of the maximum value in DC current. Okay? If we calculate the power dissipation in these two different cases, we achieve the same value of power dissipation. Power dissipation in AC is equal to what? Which I? IM or IE? IE squared times R. In DC, IM. Okay? Power AC. IE is equal to what? 10 squared times 5. Power dissipation in AC is equal to 500 watt. For DC, the same thing. 10 squared times 5. Power DC is equal to 500 watts. Okay? Which one has more power dissipation? Maximum current 10 ampere in DC or effective current 10 ampere in AC? Both the same. Okay? But if both the maximum current for both circuits are given, which one has more power dissipation? Absolutely the DC power. A circuit consists of a combination of circuit elements, AC generator, AC power supply, which provides alternating current. In AC generator, both magnet and direction changes. This is the current of AC source. Current of AC source. It has effective value, a straight line. This straight line is called the effective value, and the peak value is called the maximum value. This straight line is called what? Effective value of current or potential difference. This is the symbol of AC, and this is symbol of DC. The equation of potential difference, V instant is equal to Vm sine omega t. So this equation is based from the electromagnetic induction of Faraday. Current instant Im sine omega t. Okay? Why the energy produced by alternating current with the maximum value Im is not the same as that produced by directed current with the same value? Why power DC with the maximum value is bigger than power AC with the same maximum value of the current? Because the answer, the energies are different, because during a cycle the alternating current is at its maximum value for only an instant. However, DC current is larger at all instants, continuously 10 ampere. Because in AC generator, current is maximum value at only one instant. Okay? But in DC, all the time is equal to maximum. Effective current. What is effective current? The value of AC or DC effective current? AC. The value of AC alternating current that gives what? The same heating effect at that corresponding value directed current. I effective AC is equal to if I effective AC is equal to I maximum DC, then which one has more power dissipation? Same. Why? Because both, they have the same magnitude. Effective of AC has the same heating of directed current. Effective current has another name, which is called the RMS value. RMS current, you can represent RMS current, RMS, or IE is the same thing. There is no difference between them. Root means square. The RMS current, which is effective current, a little more than 2/3. How? For example, in AC source, where is maximum value? The peak point is the maximum value, Im or Vm. But here is what? This is IE or VE. IE, guys, IE a little bit more than 2/3 of Im. Okay? Not exactly the same, a little more than 2/3 of Im. Okay? This is IE, this is Im. As a magnitude, always the maximum value is bigger than the effective value, but effective value has the same effective of directed current. RMS current related to the maximum value as follows. IE is equal to what? Im over radical 2. Rearrange. Im is equal to what? IE times radical 2. For potential difference, the same thing. It doesn't matter. Okay? We proved this equation, the equation of Im and IE. This equation is very important. IE is equal to Im radical 2. Okay? And by using the Ohm's law also you can find IE, VE over R. Be careful. Okay? Im is equal to what? IE radical 2. VE is equal to what? Im. VE is equal to IE R. VE is equal to Vm over radical 2. Okay? Guys, when we say IE is equal to Im radical 2, can you write down like this? 1 over radical 2 Im? Why not? Yes. 1 over radical 2 is equal to what, guys? Approximately 0.7. 0.7 Im. In percent, IE is equal to how many percent of Im? 0.7 is equal to 70% of Im. 70% is equal to what? Approximately, not exactly, 2/3 of Im. A little bit more than 2/3 of Im. Okay? When alternating currents are generated, each of the maximum potential difference Vm, maximum current Im in AC generator, AC current. effective potential difference VE, effective current IE, frequency, angular speed remains what? Unchanged. During AC generator, AC current, each of the effective value, maximum effective value, yes, of current and potential difference, maximum values, frequency, angular speed doesn't change. Why? AC current. If the maximum value is 10 ampere, here is also 10 ampere, here is also 10 ampere. Is the maximum value changes in AC source? No. The maximum value for each of the potential difference and the current doesn't change. VM, IM. VM, IM doesn't change. Here is also the same thing, 10 ampere. Maximum value in AC generator doesn't change. How about the effective value? If the effective value is like 7 ampere, at each point, still 7 ampere, yes. If the effective value is equal to 20 volt, at each point 20 volt, the effective value and the maximum value of AC current doesn't change. Frequency, constant. If the frequency is constant, angular speed also constant. So in AC circuit, the maximum value, effective value, frequency, angular speed remain unchanged and doesn't change. Okay? But instantaneous values changes. Guys, the instantaneous value changes. Why? What is the value of the ampere of the current at this point? 10 ampere. How about this point? 0. This point, 2.5. Okay? The instantaneous values for each of potential difference and the current changes continuously. Let me ask you a question. In AC generator, in AC current, during the generating AC current, which of the following changes? Effective value, effective current, instantaneous value of current and potential difference, frequency. Only the instantaneous changes. The instantaneous value changes. The correct answer, the instantaneous value changes. In AC current, during generating AC source, AC current, which of the following stay unchanged, remain constant? The effective value, the maximum values, frequency and angular speed, all of them doesn't change, all of them doesn't change. All of them remain constant. Okay? But instantaneous voltage, potential difference, and instantaneous current changes continuously. For one complete cycle, full cycle, the magnitude of the average current is equal to what? 0. For one complete cycle, if we have 10 ampere here, here it should be 10 ampere negative. Average current is equal to what? 0. When average current is 0, it means that there will be no power dissipation and the wire doesn't getting warm? No. We have still power dissipation here. Why? Because the power dissipation does not depend on the direction. The average current is 0, but when we say average current is 0, it doesn't mean that there is no power dissipation. The power will dissipate and still the energy is converted from electrical energy into the thermal energy through the wire. What does this equation tell us? IE is equal to IM over radical 2. It means that if in AC source, if maximum current is equal to 5, if the maximum current is equal to 5 ampere, effective current, it should be less or more than 5 ampere, should be less than. About what? 3.5. When maximum current is 5 ampere, effective current becomes what? 3.5. In AC current, what we have? Effective value, maximum value, and instantaneous values. Question 29. In chapter review, be careful. Which quantities remain constant when alternating current? Alternating current generated. Frequency doesn't change. Maximum current doesn't change. Maximum potential difference, maximum voltage doesn't change. Effective value doesn't change. Only the instant changes. Only the instant values changes. Okay, guys. The rules of power. We have 3 different rules. Power is equal to what? I V. Okay? IEV. According to Ohm's law, V is equal to what? VE-IE-R. Okay? I is equal to what? V over R. R is equal to what? R is equal to VE over IE. According to this equation of the power, the equation of power, IE is equal to what, guys? VE over R. And instead of IE, write down what? VE over R. VE times VE square over R. VE is equal to what? IER. And instead of this VE, write down what? IER. And already in the equation we have IE, it becomes what? IE square R. This equation can be used to determine the power dissipation. Okay? And this equation can be used to find the power of the source and the power of the generator, for example. But power dissipation, the power dissipated by the current and the resistance of the resistor. Okay? Guys, Ohm's law, V is equal to what? IR. When we say VE, we have to say IE. VM, IM. VR, IR. Okay? V effective is equal to IER. VM is equal to IM times R. V across resistance, VR times R. How does the power dissipate in a resistor? In what? In resistor. Power usually dissipated in resistor. Be careful. And by an alternating current, by AC, relate to the power dissipated by directed current, DC, that has potential difference and current values that are equal the maximum value of alternating current. If both AC and DC, they have the same maximum current, what is the relation between these two power? We know that power power in DC twice as power in AC. If we rearrange, power AC is equal to what? Half power DC. The answer, the AC power is half as larger as the DC power, or power DC is twice as much or larger power AC. Guys, question 33. In a ground fault interrupter, GFI is a socket that can be used as a safety in our home, okay? Like, for example, in the presence of the electric shock at our homes, this socket is installed by the effective value, by the RMS value of the potential difference on the current. For example, if the socket is installed by the effective value like 220 volt, by the electric shock or leaking of the potential difference at some point of the wire, or in the presence of any other electrical shock, if the potential difference input more than 220 volt of the RMS value of the socket will break down. Okay? In ground fault interrupter, with the difference in the current across the outlet, which is plug, measured in terms of what? RMS value or actual value? RMS value. GFI measured in terms of what? RMS value. Okay? Question 34. Voltmeters and ammeters that measures what? AC quantities. Guys, the electricity at our homes is AC current or AC source, AC generator. Why? Because AC generator has less power dissipation. That is why we have to using AC generator. Like if you like, for example, if you want to measure the potential difference at your home by voltmeter is an electrical device that measures the potential difference, voltage. Like if you want to measure the potential difference at your home, you have to connect the wire with the plug, okay? And you will see on the screen of the voltmeter 220 volts. This 220 volts that reads by the voltmeter is the effective value. For the ammeter is the same thing, okay? For example, if the potential difference at your home is 220 volts, this 220 volt is what? The effective value or maximum value? Absolutely the effective value. Means that voltmeter and ammeter, they measures the effective value, not maximum value. Ammeter and voltmeter, they give us the effective value of potential difference and current, not maximum. But why calibrated measures the RMS value? Why ammeter and voltmeter calibrate to measure RMS value and RMS current respectively? Why would this be preferred to measuring the maximum EMF or current? Why measuring effective current is better than measuring the maximum? Because RMS value convenient, because they give the same heating effect as the same value of directed current. Because they give us the same heating of the directed current. Ohm's law, V is equal to IR. How about VE? IER. VM, IM times R. Guys, sample problem 6C. A generator with the maximum output potential difference, EM. Maximum output potential difference. It means that VM is equal to what? 205 volt connected to 100 resistor, 115 ohm. Calculate RMS potential difference. What is unknown? VE unknown. Find RMS current, IE unknown. Find maximum current, IM unknown. How many unknowns do we have? 3. Now we are finding one by one. Okay. How can we determine VE? VE is not equal to VM divided by radical 2. Yes, we studied. Okay. VE is equal to what? VM divided by radical 2. VE. VM. Do we have VM? Yes. 205. VE should be less than VM always. Is equal to 145 volt. If you draw this potential difference by a sine wave, it will be like this. The maximum value was given 205, but it is effective value 145. This is VE, this is VM. This is the relation between V maximum and effective. Okay? Yalla guys. Branch B, IE. IE is equal to what? Is equal to IM over radical. Do we have IM? No, we don't. Not allowed solving question with 2 unknowns. IM is already unknown. We cannot use this relation. What can I do in this case? Use Ohm's law. How? VE not equal to IE times R? Yes. IE is equal to what? VE over R. Do we have VE? We didn't have, but we found. We didn't have, but we found. 145 divided by resistor 115, which is equal to 1.26 ampere. What is this 1.26 ampere? This is I effective. Okay? If we found I effective, how can we determine IM? I effective is not equal to IM. Yes. How about IM? IE 1.26 times radical to 1.78 ampere. IM always bigger than IE. Practice secrecy question 1. Look. A toaster is plugged into a source of alternating EMF, potential difference, and RMS value. What do you mean by RMS value of volt? VE. VE 110 volt, effective value. The heating element is designed to convey a current with a peak value. Guys, what do you mean by peak value? Maximum value. Peak value of current, IM 10.5 ampere. Find the following. A. RMS current in the heating element. RMS current. B, the resistance of the heating. Look, do we have IM? Yes. How can you determine IE? IM divide by radical 2. IM 10 divide by radical 2. IE is equal to what? IE is equal to 7.42 ampere. Branch B, resistance of the resistor. By using Ohm's law, VE equal to IER. R is equal to what? VE over IE. VE over IE. Do we have effective potential difference? Yes, 110. Do we have current across, effective current? We didn't have, but we found 7.42. Resistance of the resistor is equal to what? 14.82 ohm. It's very easy, okay? You have to know all the equations about the effective current and maximum current and the Ohm's law. Question 2. An audio amplifier provides an alternating RMS. This is V effective. RMS, it means effective. V effective. 15 volt. Loudspeaker connected to the amplifier has a resistance 10 of 10.4 ohm. What is the RMS current? What do you mean by RMS current? I effective is unknown. In the speaker, what are the maximum value of the current and EMF? VM, IM. Look, guys, how can you determine VM? VM is equal to VE times radical 2. What is it? Sorry, IE, not VM, IE. How can you determine IE? IE, we cannot use IM over radical 2 because we don't have IM. Use Ohm's law, VE over R. Do we have VE? Yes, 15. R, 10. Branch B, or the second unknown, VM. VM is equal to VE times radical 2. IM, IE times radical. Question 3. AC generator has maximum VM. Find RMS. RMS is equal to what? VM over radical 2. RMS current. IE is equal to what? VE over R. Question 4. The largest EMF that can be placed across the certain capacitor at any instant, 451 volt. This is the largest EMF, VM. What is this 451 VM? What is RMS value? VE, VM divide radical 2. Question 27. The RMS applied EMF across the high voltage transmission line to, this is 220,000 volts. This is not 20, 220,000 volts. Okay, guys, this is 220,000. Okay, what is the maximum value? VM is equal to what? VE times radical 2. Question 28. The maximum current that can pass through the light bulb filament is maximum current. What is this? IM. Resistance. What is RMS current? RMS is equal to what? IM over radical 2. IM over what? Radical 2. What is RMS current? RMS current, RMS EMF, VE. VE is equal to what? IE. We have IE times resistance. How much power does light bulb use? Power dissipation, IE square R. Do we have IE? Yes. 0.6 under 43 squared times R. This is power dissipation. The last question in this part of this section, section 3, question 49, very good question, be careful. The alternating EMF generator is represented by the equation 245 sine 560 T. Can we write down V is equal to Vm sine omega T? Yes. What is this 245 Vm? Vm was given by the equation 245. Guys, if the equation is given, always the number before the sign represents for the Vm or Im. And the number before time is omega. Omega is equal to what? 560 rad per second. What is unknown? Use this value to find frequency. How can we determine frequency? Frequency is equal to, omega is equal to what? 2 pi f. Frequency is equal to what? Omega over 2. Omega was given by the equation 560 divided by 2.314, 89 hertz. 89 hertz. And the EMF and maximum frequency of the EMF and maximum EMF, maximum potential difference is equal to what? 245. Maximum value is equal to what? 245. Okay? It's very easy. Guys, that's all for today. Inshallah, in the next lesson, we will study the applying Ohm's law to AC circuit for pure resistance to AC circuit, pure inductance to AC circuit, and capacitor circuit with AC circuit, AC source. Thank you for listening. Keep up your best doing. Inshallah, see you next.